Good afternoon, folks. Chief Meteorologist Nick Lilia here in the Severe Weather Forecast Center. Apologize, probably should have set myself up before I was actually ready to get on here. But hey, we're watching out for the opportunity for severe weather tomorrow. I know today things have been really slow to get going. We've had pretty persistent cloud cover out there. That warm front's not moving very quickly. And even the non-surface-based convection we were anticipating, the elevated convection that we were looking at for today, showers and thunderstorms, haven't really taken off at all. And so I do apologize for that if you canceled any plans for today. We weren't looking at any severe weather for today, but I really thought we'd see at least some action out there, and so far it's held off. But for tomorrow, things are going to be a little different. For today, we've got, the showers and the green area for today, I think, does one of those with the moderate threat all the way back here in just parts of Louisiana, Texas, and that's about it. For tomorrow, there's the marginal threat, which stretches all the way up into parts of Tennessee, and then that slight risk area right about here. And if you've been watching the news the last couple of days, this is about the same circle that those SIPS analogs that I've been showing on air, that they've pretty much been spot on. Actually, I'm pretty impressed with what I've got out of those SIPS analogs, and maybe I'll pull one up here at the end of the video if I remember and I don't get too ahead of myself. But there you go, the probabilistic, you're looking at 5 to 15% chance for showers and storms that do turn severe. Main threats for tomorrow across the Pine Belt: wind and isolated tornadoes. I don't think we'll have to worry about hail for tomorrow, big hail. Maybe some small hail in there, but I don't think we necessarily have to worry about big hail down here like they do just off to our north. Of course, the National Weather Service out of Jackson, always great at getting ahead of these things. They're watching out for damaging wind, large hail, and tornadoes. I think the large hail is going to be kind of north and west. It'll probably get into Jackson a little bit, but I don't think we'll have to worry necessarily about any large hail. The damaging winds, yes, that'll come with the main line that comes through, and any isolated cells that pop up. The isolated tornado threat, I think, right now is strictly for any discrete cell that does fire up out ahead of the line. And when they talk about these times right here from the Weather Service, I think these are strictly for that line of showers and storms that we're anticipating to move through the area. Any discrete cell, any individual cell away from that line that does fire up through the day, I think will have an opportunity to produce an isolated tornado given the environment that it will be building into. So let's take a look at it. I know a lot of you folks are starting to get used to seeing all of these maps, which I love, frankly. But let's take a look at the setup for tomorrow. You've got your area of low pressure back here. You've got the isobars. Again, we're looking for spreading across any one particular area. And I would say we would have that right in here. Okay, so we'll clear that out. I'm going to leave this circle up right where we've got that spreading, and we're going to take a look at the VORT. Okay, there's your VORT right back in here at 500 millibars. Bring it down to 700. Where do we have lift? We've got the most vertical velocity right in there. I'm going to leave all these circles up. Where do we have the most moisture? Well, it looks like kind of right in this area or so, leaving the circles up as we take it down to Cape. How much instability do we have? The NAM right now, it really isn't talking too much about instability. It's got everything down off to the south. Look at this. This is as far north as that 750 line gets. Stays down in the Gulf. I think we're going to have a nose of this up across our area. In fact, I anticipate Cape levels, that's instability. Instability levels, Cape levels up above 1,000 joules per kilogram. As you can see down here, that's the math. Don't necessarily worry so much about the math. But anytime you get above 1,000, that's pretty good down here, especially in the cold season. And I think we're definitely going to have that as we move through the afternoon for tomorrow. I'm going to leave all these circles up here, because now we're going to go ahead and take a look. Actually, you know what? I'm not. Hold on. I lied. Sorry. I'm going to clear this out really fast. I want to point out the reason that I think that we're going to have higher Cape values tomorrow than the NAM is suggesting. Here's just surface temperature and surface wind. So we've got wind and temp on here. The temperature, see this 70-degree line? I'm gonna draw out this 70-degree line. It kind of goes up like that. We got another a little bit kind of in there, and then it kind of goes over. So everywhere south of this line, so all back in here, that's 70-degree air. And if we get 70-degree air to filter up where it's saying with a nice southerly or southeasterly wind, That with it, that's going to bring a lot of moisture with it, and you know, you can just lay dew point right on top of that almost. I mean, you can see the fingers of, and this orange right here, this is a 65-degree dew point line. You can see the fingers of 65-degree dew point. A southeasterly flow, or a southerly flow, or even a southwesterly flow off the Gulf into parts of Louisiana, Mississippi, Alabama, and the Florida Panhandle. With a dew point at 65, the lapse rates really aren't great with this system. The cold air aloft that we're talking about, it's really not that cold. But when you've got temperatures that are suggested to be in the 70s and dew points in the mid to upper 60s, I think we're going to be hard-pressed to keep that instability down. If we get areas where we break out into some sunshine for 30 minutes, an hour, or 2 hours, heaven forbid, especially down along the south coast of Mississippi and Alabama, that's only going to warm things up farther, and then that air is going to move across that. I just think this does not line up with that. Again, sometimes this happens. I could be completely off base, but 750 joules per kilogram when you've got temperatures, some models say in the mid to upper 70s, dew points in the mid to upper 60s. Some models come back with dew points in the low 70s. That's a lot of moisture, folks, and you would be hard-pressed to have that much moisture and a temperature at 70 degrees and a CAPE of about 750. You know, and just to kind of point this out, if we go up air temperature at 500 millibars, this is what we're looking at lapse rate. I mean, here's the -10 line. Everything north of that is cooler than -10. Here's your 15. So you're in between 10 degrees and 15 degrees Celsius, below zero at that point. So, you know, I mean, maybe -11, maybe a -12 for this area here. And, you know, if you're in there shoving 65-degree dew point underneath, again, 12 degrees C below zero at 500 millibars, I just think you're hard-pressed to only end up with 750 or less than 750 joules per kilogram. Just personal thoughts. The lifted index is decent, out ahead of the front. You know, down here between 3 and 4, a -3 and a -4. And again, we can kind of circle that same area. You know what I'm going to do here? Look at this. This is interesting. There's your lifted index. There's your dew point. Okay, so that's what you're doing. You're pushing the air in here, and then you're taking that moist air and you're lifting it up. And again, lifted indices at -3 and -4 aren't necessarily terrific, you know, but it's pretty good. In the summer, by the way, around here, we can get lifted indices at -8, -9, -10 without even sneezing. And CAPE values in the summer can get pretty high as well. But you know, if you're in here with a -4, even a -3, and you're underneath 10 degrees below zero Celsius at 500 millibars, I don't know. It just, again, personal thoughts here. Your shear right now, anywhere north of about there, you're looking at -30. Anywhere north of about here, I'll line that up again. Again, it's pretty sharp contrast in here. So we've got 30 here, and we've got, oh, that's 60 there. So we've got 60 there, and you can line that up with where you've got instability. So now you've got areas of a lot of instability underneath, building into, I should say, shear values between 30 and 60 knots or so. Again, there's your dew point. There's your lifted index. Okay, and then there's your shear. And again, that's surface to 500 millibar shear. If you bring it down and you talk about 3K surface relative helicity, and this is basically the mathematical equation that goes into if a storm's moving this way, you know, and the shear, you got a wind change with height, and then you've got inflow coming in a different direction. Basically, it's that inflow versus the wind shear that you're looking at. Anytime you can get above 200 down along the Gulf Coast in the cold season, you can probably spin yourself up a stronger storm. Above 250, you're starting to get into that severe range. Above 350, you're starting to talk about tornadic thunderstorms. And you can see the key here. Anywhere where you get that darker red, you're at about 350. We've got some darker red up here, maybe a little hint of it there. But for the most part, across the Pine Belt, it's between about 250 and 300 or so. And we can go back, and again, the reason I like doing this between all these wonderful tabs here is you can kind of go back and look and see you've got the helicity, but it doesn't line up necessarily with where the instability is. But again, that knows of those higher dew points, and so that's where we're kind of thinking, and that's I think where the SPC is at. Now this map doesn't necessarily line up, but you know, if you take that circle and you superimpose it back over here, I mean, you're looking at you know, a circle kind of right in like that, and it's right where that nose is, and it's right where you've got the surface relative helicity up there around 300. And again, if you bring it down to 1K, this is kind of that lower level of the atmosphere shear, or helicity, I should say, that we look at in those discrete cells that we're watching. How much helicity can it pull on? And it looks like we've got up over 300 to 350 to perhaps even approaching 400 in the very lowest levels of the atmosphere. So what does this all mean? And I know there's some people that get to the end of these and they go, Nick, I learned a lot, but I didn't get a forecast. Right now, and this is probably going to change by the time we get on the news tonight, I think everywhere has a risk for severe weather across the area. I think there's going to be an elevated risk of severe weather, probably north of a line. Let's go north of this line here, across our area. A place that I'm more concerned about tornadic development, just like last night, I think is going to be kind of right in this ballpark here or so. But you can't rule that out all across some of our eastern counties. This does include Laurel, Hattiesburg, Collins, Waynesboro, Bay Springs, all the way even back up toward Yucutta and Meridian as well. That doesn't mean down here you're not concerned about severe weather if you're down along the coast. I still think you have to worry about it. But again, I think about a line of about right there and points north of that, and then kind of right across some of our northeastern counties. That's where I'm most concerned, because that's where we've got the most helicity, and I still think that we're going to get enough instability off of the Gulf. I think that you know, if I could go back, this I think is kind of garbage. Let's take a look at the GFS, see what it says into the afternoon. See, this is a little better, but it's also, that's 15. Hold on, let's bring us back into the afternoon. Yeah, this is much better. See, this lines up. See here, let's line this up. This is a different model completely, but if you go back and you take a look at where that nose is of higher dew points, it almost lines up. And again, because it's a different model, it's not going to line up perfectly. But that, I think, gives you a better idea of what we're talking about. We've got 2,000 joules per kilogram back here just off the coast, and so you're looking at about 1,000 or so, which is where I really think that we're going to be as we head into the afternoon for tomorrow. So again, there's that slight risk, and we can go back. Here's your severe weather again. And now I'm going to take a look at some of the numbers as well, because I know people, they get confused by all the math sometimes. Don't worry about the math. People have asked me, they go, hey, well, how did you come up with that? Don't worry about it. If you want to know, I'll explain it to you. I usually do in a message. But don't get too hung up on the math, because there's a lot of it. And I don't even really like the math, I'll be honest. I wasn't a very good math student. Kids don't listen to me. So your GFS, you're talking about, again, 500 millibar temps. That's what we're talking about in terms of the instability. All the models, all across the board. By the way, this wrap, this is for 12Z tomorrow morning. So that would be about 7 a.m., 6, 7 a.m. That's usually when they take the soundings, by the way, from the National Weather Service. So all across the board, you're sitting at 11 to 12 degrees below zero. You've got plenty of wind coming in and out of the south and west. At 700 millibars or so, you're talking about temperatures hovering about 5, 6, 7 degrees or so. You've got plenty of wind out of the southwest. Dew points are interesting, and the reason this is interesting, remember we were talking about that 700 millibar, hold on, let's go back here. The 700 millibar right here, the vertical velocity. And this has to do with the transport of air vertically across the atmosphere, because the wind doesn't just go horizontal. Every once in a while it goes vertical. Really slow, but it goes. And so where you've got that vertical velocity, if you're moving parcels of air up at 700 millibars, and if you're doing it quickly, on top of that, you're taking with it some moisture that you probably picked up from further down in the atmosphere. That helps to build these showers and thunderstorms. This helps make things a little more severe. And I can test this for you by showing you something here in a second. We can show you, here we go, there are K-index down here. And the K-index right here, right there it is, folks, is what we're talking about. A convective potential, small, moderate, high. Okay, cool. So what does that 700 millibar dew point do? Well, if you've got a dew point of, say, 13 down at the surface, and you've got a dew point of, again, our temperature, for example, in this wrap is at 7 degrees. Dew point can never get higher than the temperature. Let's put in a 6 there. And take a look at what happens to our K-index down here. It jumps up. So we didn't really change from, we're still moderate to moderate, but we're a higher moderate rather than where we were before, which was a 32. So that's, again, if you're moving that parcel of air with lots of moisture in it up to 700 millibars, you can make more severe thunderstorms. And again, here's a look at the CAPE for each one. The NAM, this was the model we were just looking at 750. I gave us 750 even though that line was a little further to the south. I easily could have written in 600 here because that's what the model is saying, but I think that it's hiccuping this afternoon, so I think it'll be around 750 according to that model. The forecast, I haven't put in a forecast here, but I'm thinking we're going to be up closer to where the GFS is here, around 1200 or so, perhaps approaching 13 or 1400 into the afternoon if we can get some clearing. You can look at all your shear in here. Here's your helicity. That was the spin that we were just talking about, 300s, except for the SREF, which comes in at 250. And this gives us your EHI, which if we go up here is a measurement of, it's a good, not necessarily a measurement, it's a good equation to show us if we're just going to have supercells, and if those supercells are going to be able to produce tornadoes given how much instability there is and how much shear that we have, and or how much helicity we have. The Energy Helicity Index is, by the way, what this stands for here. And again, you can see supercells, F2, F3, F4, F5. It's not the enhanced Fujita scale, just kind of a rule of thumb. Anywhere between 1.4, 1.1, 1.6, all the way up to 2.25. And again, our average, what I like to do is I take all of these, the big four, GFS, NAM, WRF, SREF, put it in an average. Average plus is with the wrap for tomorrow morning soundings. Each of these soundings is from the afternoon, so this doesn't necessarily line up. That's why it's kind of an average plus. I'll throw in a forecast here every once in a while, but we're talking about sweat values up over 400 for your GFS and your NAM, just below it for your WRF, and 324 on the SREF. And if you go up to the sweat, that means that severe is possible, and according to the other two guys, tornadic storms are also possible. For your totals, up around 50 or so on most of these, which means that we've got likely thunderstorms with isolated severe storms possible. K-index in the low to mid 30s, except the SREF, which comes in the upper 20s. Either way, moderate convective potential, and your BRN, which is supercells favorable if you are below 45. The optimum, though, is down here in the teens, and it looks like we've got a handful of teens down there as well. You look at the SREF. This hasn't changed, by the way, since the last video that I put out. We fall underneath the parameters, the historical parameters for creating a tornado across the Pine Belt. So that's one thing to keep in mind as well. So when it's all said and done, you look at all the numbers and you say, okay, you can go off the checklist. Do we have severe potential? Yes. Supercells likely? Yes. We move down here and you say, okay, we're in the 50s, isolated severe storms, moderate convective potential, and we're in the optimum range down here. So we've pretty much made our checklist. We've checked everything off to see if we can make some severe thunderstorms and severe weather, and unfortunately we've done it. And again, north of that line, specifically in our northeastern counties, is where I'm kind of concerned right now. Okay, so I hope I've answered all your questions and I went through everything on here. Here, I'll clear this out for you guys, and I'll make the screen big again. Hope I've answered all the questions. If you have any more, feel free to comment here or ask them on my Facebook page. I'll try to answer them as best I can as we move through the afternoon. Make sure you tune in at 5, 6, 6:30, and 10 o'clock as this forecast will continue to kind of evolve tonight and through the day tomorrow. Megan and I will be here tomorrow should anything crazy happen, and we will keep you guys informed as to all the bad weather that's happening, where it's happening, how long it's going to stick around. So there's your forecast for right now, and as always, thanks so much for checking us out here with the extra details from the Severe Weather Forecast Center.